Cpctc. Corresponding parts of congruent triangles are congruent. Alright, so this is probably the biggest tongue twister we're going to have in this course, but one of the most important. So let's think about what that means for a second. Corresponding parts of congruent triangles are congruent. Well, that makes sense, right? If congruent triangles, they're the same triangles, and the corresponding parts of those triangles are going to be the same. They're going to be congruent. So let's actually use this in a proof. So we're given a circle here with the center P. So we're given a circle P. And let's try to conclude that AB is congruent to CD. Okay? Simple enough. Let's start with our statements. The first thing that we're going to put down is our given information. We're given a circle P. So P represents a circle. And that's going to actually be pretty important. So that's our given information. And then our next statement, let's look at AB, okay, and CD. All right, well, a good thing to do here would be if we're trying to prove that AB and CD are congruent, and maybe these triangles, these two triangles that I see here in this circle, maybe these two triangles are congruent, and if the triangles are congruent, then we can prove that the two line segments are congruent because they're corresponding parts. If I picked up that top triangle and kind of turned it over and placed it on top of the bottom triangle, then those sides, AB and CD, would correspond. They would line up. Okay, so let's start by saying a property of the circle. And this is going to help us actually lead to proving these triangles' congruence. And I think what we should use to prove the triangle's congruence is side angle side. Because I know that radii of a circle are always the same distance. They're always the same. They're always congruent. The radii, the segments of that are the radii, they're going to be congruent. So I know that PA will be congruent to PB, PC, and PD. So PB, PC, and PD. Okay, and this is just because radii of a circle are congruent. That's just always true. That's just a property of circles. Okay, so now that I've actually proved that PA and PB are congruent, and then PC and PD are congruent, so now I already have two sides. All I need is this angle right here, and if we can prove that this pair of angles right here are congruent, then we're good to go. And I think the best way to do this is through vertical angles. They're a vertical angle pair, are they not? So we can actually just say here that angle CPD is congruent to angle APB, right? APB. And that's because vertical angles are congruent. Vertical angles are congruent. Okay. So now we have side angle side. So let's prove these triangles' congruence. We can say that triangle CPD is congruent to triangle APB. And this is due to side, angle, side. Now when we put side, angle, side, or any of these postulates in the reasons area, we want to indicate which other statements we used that involve the side, angle, and the side. So the first side that we're using was listed in statement 2, the angle was listed in statement 3, and then the last side was also listed in statement 2. So we're just going to put side, angle, side 2, 3, 2. All right, and then we're pretty much there. We've just proved the triangle's congruence. So as we stated before, Cpctc, corresponding parts of congruent triangles are congruent. We can make this that AB is congruent to CD, and this is due to, no, well, I didn't do that for any of the others, so I'll put a dot. And this is due to Cpctc. Okay, perfect.